what I'm going to talk today is building modular business systems with Spring integration. And what's actually not on the title is that what we're going to see is also how we can apply those Spring integration components, actually deploying them to Spring XD as well. So first and foremost, let me introduce myself. My name is Marius Bogoevici. I'm working for Pivotal. I'm on the Spring XD team. In the past, I've worked on the Spring integration project. I've been a Spring consultant. I also had experience in the Java EE world. But the overarching interest for me is enterprise application integration. And this presentation has kind of stemmed from that interest. From after developing a number of systems with Spring integration, it kind of became obvious that you want to have some kind of way of organizing your code, of organizing it into modules, or building an architecture of not necessarily reusable components, but something of a granularity that you can manage and understand, right? And so basically, the question here is, like, when we talk about modularity, is what kind of modularity are we looking at? Because modularity means a lot of things to a lot of people. Everyone has their own understanding of the word. If you're asking some, they would tell you, OK, it's the way I can actually break my application into libraries and include them and make my application work together. If you ask the Jigsaw or SGI folks, they would tell you that, oh, modularity definitely deals with class loading, with dependency management, visibility. So as I said, my interest in this talk, and what this talk is about, is mostly about modularity through services. Not all kinds of services. How many of you have heard the word microservices uttered more than 3 times today? It's well, it's somehow it's the fashion nowadays, but it's more than that. Like it makes sense when you look at the opportunities that we have right now to virtualize systems, to deploy deploy components fast. So having really granular components that you can actually deploy, start, and so on makes sense. The question is, how many of you have heard, speaking of microservices outside the context of HTTP or REST? One person. So it's kind of telling that 2 persons. So it's kind of telling because that's the dominant discussion nowadays. Why? Because we've built RESTful services. We know how to build them. It's some sort of a dominant paradigm. But it's not necessarily a prerequisite for the notion of having a microservice. Basically, the same principles apply even outside the HTTP, even outside the remote procedure call, even outside the HTTP service kind of an environment. They really apply in other situations, like event-driven architectures, message-driven architectures, and so on. What we need to take away from that is the core principles. So basically, what do we want to achieve through that? We want to break away from monolithic architectures. Why do we want to do that? Because they scale, because it's hard to scale them. Because essentially, if I want to create multiple instances of, if I want to increase the computing power for my application, it's really hard if I have to deploy the entire thing on another node or another node or another node. What I really want to do is basically have my components split along business features, and then deploy them as standalone components. That gives me the opportunity of deploying, upgrading, maintaining them independently, but also scaling them independently, right? And basically this has nothing to do with HTTP, has nothing to do with anything like that. In our case, like for Spring integration, for example, one needs to look at the architectural style behind it. Pipes and filters. How many of you are familiar with the concept? Quite good. Basically, for everyone else, the core idea behind it is that rather than organize, like we can always, like a business processing, like a business system, can be broken down into a stream of processing components called filters. Now, filters is some kind of a loaded word because they usually kind of brings to mind the idea of filtering out information or removing information. It's not like that. They just do transformations. Such filters are connected with pipes, right? Pipes are essentially point-to-point connections to which these filters communicate. Each filter knows only what pipes it receives messages from, what pipes it sends messages to. Okay, so they can send to multiple pipes, so we can have more complexity like that. But the point is that none of these components actually cares about what's upstream or downstream from them. They're isolated, they communicate in a very decoupled fashion. Now, that kind of rings a bell and kind of ties pretty well into the, let's say, into the concepts of microservices. Independent components, decoupling, isolation along business features. In particular, this concept is implemented, the way it's implemented in Spring integration relies on structural components, like there are a few core components: channels, endpoints, and messages. Channels play the roles of pipes. Endpoints play the role of filters, and messages are, well, messages. Besides that, there is Spring integration implements a wide arrangement of enterprise application integration patterns, right? Things such as a router, or a splitter, or a service activator, or a channel adapter, and many others like wiretap, which I haven't mentioned here in this discussion. The point is that it is a framework that is very well suited to implement this pipes and filters architecture that would help us to build modular components. How many of you have used Spring integration? Excellent. So probably you will be familiar with the demo that we're going to go through later, because we find that Spring integration fits perfectly the model of building decoupled architectures, and we are going to illustrate that through I'm going to actually start and do an example of how a system can actually transform from an integrated monolithic application that does everything into a decoupled modular, if you want, microservices oriented. I said that a number of times today, so I'm going to say it again. Architecture. And we are going to see how exactly how that system would actually build and deploy. Like, we're going to see how that deploys and how we can create different instances, and even how we can actually use Spring XD to manage it. So we're going to have, in order to transform this system, we'd actually follow multiple steps. The first step is going to be that we're going to decompose the application into logical partitions. Then we're going to identify what do we want to split and what are the lines under along which we want to split the business logic. Then, even like in the first phase, we're just going to keep the same application monolithic. We're just going to organize it a little better. Then, we're going to split it into independently running components. Finally, we're going to, that we manage ourselves. Finally, we're going to deploy it on SpringXD, and we'll see how that looks like. Our tools for that are SpringBoot. How many of you are familiar with SpringBoot or have tried it? So that's great. How'd you like it? Awesome. I see thumbs lifted, so that's good. The thing with SpringBoot is that you'll see that it makes it very, very easy to deploy independent instances of the application. And that's actually a factor that's very important for the partitioning to actually make sense. It doesn't really make sense to partition something if it's completely if it's very, very hard to deploy. Obviously, our other tool is Spring Integration, which implements the component model that we are looking for. And at the end of the day is, as I mentioned, SpringXD. So what's the business process that we're going to split? How many of you recognize it? OK, so you have used Spring Integration. I know it. It's the cafe example. It's one of the Spring Integration samples, the cafe. It's not a particularly complicated example. But it actually captures pretty well the idea of having multiple steps in processing. So basically, we initially receive orders for a cafe. We actually have the orders are split and sent to a barista processor that actually routes them to so they are split and actually routed to separate channels, like cold drinks and hot drinks, where we have a transformer that processes these drink orders, into the actual drinks. But finally, the final order must be delivered to the customer. So by the end of the process, we have an aggregator that actually puts the drinks together and creates a delivery. So, as I said, it's not very complicated to understand, but it can benefit from drawing some logical boundaries. So, I'm actually looking at this example and say, well, how about we conceptually separate what happens in order processing, what happens in drink preparation, and what happens in delivery. So we'll do just that. We draw these lines, and all of a sudden, our diagram becomes much more simple. We're actually having just 3 steps that we need to worry about. Of course, each of these steps inside of it, it's still the sophisticated component that it originated from. The point is that once I got to this point, I can actually apply different strategies for making drinks. I can upgrade. I can add new types of drinks without modifying the entire application. Or I can improve performance. Or I can do other things like, for example, adding more components of each type. And we'll actually see how we can scale up one of these phases by just adding a new component into the bus. Coming back to the pipes and filters architecture and looking again at the whole picture, well, it becomes clear that we can look at these partitions themselves as filters. Like if we look them as a black box, they really, all of them have input and output channels. Something happens inside of them. They do transformations. And again, that helps us having a better view of the problem, but also manage it a little better when we decide, for example, to deploy. Even the partitioning, like what I showed you is one example of doing the partitioning. We can do it in many ways. Like I could have split, for example, the process of making drinks and had the cold drinks and hot drinks processors separates components. I mean, that's equally acceptable. There is no real silver bullet in how you do it. It's more about how it reflects on your process. And conversely, such a system, which is actually, as I said, it's a filter by itself, can become part of a bigger process. For example, our application may decide that they want to serve meals along with drinks. So all of a sudden, I get separate. I have a bigger overarching architecture that incorporates this as a part. You know, it's this infinite recursion. It's like, as the saying goes, it's turtles all the way down. Basically, you can go as far as you want with partitioning. You will have to stop at the point where it ceases, like splitting the system even more, ceases to make sense from a logical perspective. Again, but inside this, like inside all these components, at the end of the day, the way they actually interact with each other is that you can always look at the higher level component and you can see like some nested components inside it, or even nested modules. In our case, the modularity, like the way we want to achieve the modularization for our Spring integration applications is essentially by, as you've seen in the example, I'm creating logical groups of channels and endpoints. We use business criteria for partitioning. Each module is self-contained. So what we would want to do is basically to have a module communicate, like a module having a number of inbound and outbound channels. And basically, we use the decoupled communications via channels for integrating all of them. The same method works with XML on annotations. In this, like in the demo that I'm going to do, I'm actually using XML heavier, like more. The reason for that is also that it's very good from a visual perspective. It kind of helps visualizing what we are partitioning and splitting. But the reality is that everything applies equally well for annotations too. OK. So that was kind of the talking part of the presentation. What we're going to do now is we move into the, let's say, coding part. And we're actually going to start splitting our example. So the first thing to do for me is to bring up the initial example. OK. Think about it is OK. Is the font size OK? Can you, how well can you see in the back? Good. Okay, so what we are starting with, and fortunately I have to scroll around a little bit. Retina views are definitely not made for such small resolutions. So what happens here is basically that we have the entire cafe example in one XML. A lot of you know it already. What is different from the example that we had that you will find in the Spring integration distribution is that rather than having a gateway for sending orders, we actually have an inbound channel adapter. So what I'm going to be able to do is I'm going to post some JSON to this component, and you'll see basically the different endpoints doing the jobs and finally assembling the order and creating the delivery. So this is the whole context. As you see, everything is in one place. The other difference is that this example uses, you'll actually be able to get it from GitHub. The other example is that this example uses SpringBoot. So the nice thing about it is that it's very, very easy to start and run the application, and also to specify any dependencies that I need. So essentially, all I need to do is to tell SpringBoot that I want Spring Starter integration, and I want Tomcat on the class path so that I actually can have the HTTP endpoint, and everything else is taken care of. Which is actually very, very cool, because when I will want to create more components and I want to run them easily, I want to have that kind of flexibility in place. And actually, as proof, here is what I'm going to do. So I'm going to go here. So now, the other nice thing about SpringBoot is that I can launch my application directly from Gradle very simply. So I'm going to do Gradle boot run. Oh, it's Gradle W. So you see the application context being created. Everything starts in 3 seconds. That's pretty fast. So right now I have a running Spring integration application that can process my orders and do all kinds of work. So what I'm going to do next is I am going to post an order to HTTP. So I'm going to do this. I'm going to do, so you see, okay, let me try to make this a bit more readable. So what I'm going to do next is, say I'm posting this order that has a number of items. I have an espresso, I have a mocha, and I'm expecting that my Spring integration application, my barista will be able to create the drinks and assemble them. And this is what happens. Now, you have to bear in mind that the example itself has some delays in creating the drinks. So intentionally, there is a thread sleep. There is a blocking thread sleep inside the processor so we can actually visualize concurrency inside the system. But as you see in the end, my order is created. Everything works. OK, so this is where we are starting from. What are we going to do next? Well, the next thing that comes to mind is we are going to start breaking things into pieces. So the first idea is I don't want to have a large context that has everything. I want everything split into parts. So the first thing that I did here was just to break things up. I created multiple contexts, and basically each one of them captures a phase of the application. So I have my input here that actually creates objects, right? I have order processing, which is the splitter. As you see, each of these fragments specifies a number of specifies channels. But what happens is that in order to avoid any overlap, some channels are specified in some of the fragments, some channels are specified in the other fragments, and I rely on the whole thing to bring them together. So basically, if you look at the, so if I look at all the components here, for example, the drink preparation component knows that there's going to be a channel called drinks that it is going to have to receive drinks from, and so on. Again, how do we put them together? Well, again, we just merge everything and rely on Spring to do its job and merge all the context definitions in one piece. So if I'm running this example again, I'm going to run it with this. Again, Gradle. Okay. And I can try sending the same order again, and I should see that it works. Now, what the logical partitioning has produced is not a change in behavior, is not necessarily a fundamental change in the architecture of the application, but it's a first step. It's the first step towards kind of starting to reason a little bit about how do I want to partition my application. So again, everything worked fine. What we achieved in this point is the division, like as I said, simpler components. We got the division by business functionality. But what's there not to like about it? Well, most of these fragments are incomplete. If I try, for example, to create an application context out to one of them, it's going to break because it's missing a channel that's defined everywhere. So channels, for a lot of these components, channels are defined, like the channels that they depend on are defined in another XML fragment. And I don't really like that. However, so far, this gives me the option of splitting the application into independent libraries. So you can imagine the different parts of the system actually having their own, like having multiple jars containing components, each one of them bringing its own fragment, and then relying on a build process to build them together. And we can use conventions like things, for example, like everything that's on the class path and starts with cafe. It's cafe-star.xml. So you can reason about that. It's not a fundamental way of partitioning. Like it's not a very decoupled partitioning, so to speak. What I like to do is kind of go in another direction and have these fragments more self-contained. So the second idea that I can come up with is I didn't like the fact that there were some components that actually didn't have their input and output channels. So what I'm going to do, rather than having, I'm going to make sure that each of these fragments has an input and an output channel. Of course, that comes with a price. I have to be aware of namespaces. So again, they have to know that they cannot use the same names for the inputs. I cannot really follow conventions. I have to call them like order processing input. I have to be very creative about that. But at least, at this point, if I take any of these fragments, if I take, for example, remember how I said that drink preparation, for example, relied on an external drink channels that someone will provide. Like right now, if I take any of these fragments and put them into a context of its own, they're going to work. And that is a good thing for a number of reasons. Of course, partitioning is one, but it's also testability. I can really create a context that has only that component and test only that scenario, and that's a good thing, because I really want to be able to make my tests as granular and as possible. How do I bring them together? Well, that's a different thing. Now, of course, if, for example, order processing produces split orders and drink preparation gets its orders from the channel drinks, they're not going to talk to each other. So we have to link them together. And this is where a specific component of Spring integration, the bridge, comes into place. So basically what I can do is I can do things like this. Bridge input channel split orders to drinks. And I'm going to make sure, and that's going to make sure that they are actually linked in a single component. What's there to like about this? What's there not to like about this? Well, as I said, the fact that I have, like my fragments have become real standalone XML components is a thing to like. The fact that I have to do this very, very verbose, so and so. However, there are ways, bear in mind about this bridging thing when we actually get to Spring XD. So I'm going to leave it like this, and I'm going to move on and say, well, now that I have everything in its own isolated context, why don't I start and build separate applications, really separate? I'm going to do that. Well, obviously, there has to be a way for the different, for these different components to talk to each other. How can I achieve that? Through channel adapters. So I'm going to need some form of transport to connect the components. How many of you have used channel adapters in your applications? Good. So basically, what for everyone else, what channel adapters do is basically they allow you to send or receive data from an external transport, right, and treat it logically as if it was a channel in your application. So what I'm going to do next is we're going to take this example and actually break it. And not only that, but we're going to connect all these parts to RabbitMQ, which is one of the variants that you have. You have a lot of options. In particular, like RabbitMQ because it's very performant and it's actually a very scalable solutions for for creating distributed systems. Okay, so now that we did that, we can actually let's see. Let me. Let's go to the next implementation. Honestly, I wish it were possible to do this as a live coding thing, because that's when you actually get the most of the most benefit of it. But it's kind of really too long for like an hour and a half is not enough time to put all this together. So We have this, we have the system actually. So what I did was I created 3 separate projects. Each one exists on its own. Each one is its own standalone application. Everything's fine. Obviously, they have, let me go to the drinks example because that's one interesting. What they do is, besides their internal logic, right? They are connected to the outside world through these channel adapters. So besides, for example, I'm having the old fragment that I used here for drinks preparation, but I also have an inbound adapter that brings me data from a channel from RabbitMQ called split orders. And then my results are going to be written to an external queue called prepare drinks, for example. That's for the drink preparation components, right? Conversely, the order preparation part will produce, we'll take the results of splitting the orders, and we'll actually write those split orders on a specific RabbitMQ queue that the other component is listening to. Yes?
Just a quick question. As you go from module to module, you are converting to JSON and unmarshalling on the other side.
Yes.
What would you say to people that might say, oh, that's too much overhead? It's not really that much, is it?
Well, JSON conversion by itself is pretty fast. Like when you think of overhead, XML is the one that you actually have to really worry about. The problem with distributed systems is that you will have to convert to a byte form, to a byte array one way or another, because this is how RabbitMQ operates. Now, if you're going to use serialized classes, for example, for that, you might have the surprise that deserialization is quite expensive as well. So that's one thing that you have to consider. Any way you do it, there is going to be, data travels over the network. Even if it's on the same machine, it's going to travel through a network interface. There's going to be marshalling and unmarshalling. So the best thing that you can do there is to choose the marshalling strategy, to choose the marshalling strategy that you like. I can argue that there could be better ways of doing it than JSON. So yes, there are serialization libraries that are pretty good, and if you want to use that, then it's fine. Bear in mind that this is an example. So JSON actually has the advantage of kind of bringing a bit more visibility into the mix. But I get your point. There is an overhead, and you have to bear that. Actually, that's a good question, and I'm glad that you asked. All this partitioning works as long as there is a benefit in scaling up the other systems, or really deploying, or something like that. As you've heard probably, microservices are not a free lunch. It's often said. So there's no such thing as a free lunch either. So basically, the thing is, you can't split. You can't go crazy and just break things down and expect for things to work. There is going to be some point where you actually have to worry about the system being distributed and the overhead that you're introducing. So you have to be mindful about that. But again, for certain types, especially when you want to, if for example, the overhead of processing that on a single machine, on a single node, is much higher than the cost of serializing and deserializing, then it's a good option for you. Basically, let me just show you a little bit. This is how our deployment looks like in the end. Right? It's 3 different Spring Boot instances, each one of them running a part of the application that talk to each other through RabbitMQ endpoints. And I'm going to launch that just now. And we're going to do something even cooler after that. Okay. Now, this distribution and reliance on a message queue has other benefits than just a simple thing. It'd be like just a microservice architecture or scaling independently and so on. It's also failover resilient. So what happens, for example, watch this. So I'm going to start one of the components, the one that actually okay. There's no such thing as boor run. Okay. Except I didn't start RabbitMQ. Okay, I did start RabbitMQ. Sorry about that. Okay. So we have that. I'm going to send the message, and nothing happens, of course, because I don't have the other components into play. But now, let me start quickly the other ones. Okay. Oh, and watch this. As soon as I started that component, it already started producing drinks. Why? Because the first component had actually written into the message queue. Okay. Hold on for a second. Okay. Then I'm deploying the final component, which is cafe delivery. And it aggregates the order. And I can go crazy like this, sending, let me just send another message. And actually, let me send a more complicated one. I'm going to send 2 requests in a single step. I'm going to send 3. So, you see the barista actually working hard to prepare the drinks, and then this, like the waiter aggregating them immediately. Now, what I want to do is, okay, fine. I I like this complete architecture that the barista is too slow. What I want to do is deploy another barista. So what I'm going to do next is simply go here and start another barista instance. So what I'm going to do is just send orders like crazy. And see what happens is that both baristas are actually like, see these two processes here? Like the two tabs on the, like the second and the one on the right? They're basically, okay, let me separate that to make things a little bit more easier to view. Oh, sorry, this was the barista I was looking at. So anyhow, as long as I send requests, you can see all the components. I can add the third one, a fourth one, a fifth one, and scale, right? And that's one of the benefits of actually modularizing my architecture and splitting things up. And right now I have complete control over how do I create and deploy such instances. And it's eventually, if you look at it, it's logically it's the same application, but all of a sudden it has a completely different structure. Yes?
How did you get it to obviously run the same board and just handle it seamlessly like that? Where
I'm sorry?
How did you, once you started up the second barista, how did it just pick up everything that you
That's a good question. So how did it pick up, how did the second instance just start and pick up orders? Basically they listen, it's a virtue of the fact that they both listen to the same queue in RabbitMQ, so they're basically concurrent consumers, right? So essentially one of them will receive an order, like one of them will receive the message, and the other one, will basically, while the other one is processing, they can take over the additional workload.
Okay, so you didn't need to define any kind of threading or anything within each of the SpringBoots?
No, I haven't. You could define, like if you wanted to define, these are, like, mind you, these are independent processes. Like they are completely operating system processes. Like the best demo probably would have been with them running even on different machines. Like popping them up like in a virtualization environment. We can just say, okay, I want another machine that's able to handle this and runs this particular process. So that would basically be kind of the best logical illustration of what happens over there.
It looks to me like what you're showing is you have a big monolithic system, you break it down, still in memory, like you showed with the bridges, then you split them apart, they're still running in the same box, but then you can even go further and put them in different boxes.
That is correct. That is correct. That is correct. Basically, the fact that I'm running them on a single machine is just because I have a single machine. But probably the best way to actually run them would be to have them as really separate instances. And then you start seeing the benefits of that.
But if you're starting with a monolith, you probably want to go step by step and executing on each step until you feel more comfortable with it,
yes.
Whatever, until you get to the point.
Yes, yes. And that actually, this was the whole idea of starting the partitioning, because like you can stop like at any point you want. Like even the fact that you have different libraries that have a part of your message bus and that you can load together and build separately and just add that to the build can be a benefit at times. But as I said, the real goal, the real benefit is to build things like that. And again, one thing that makes it possible is exactly this, like the way, like it's exactly how flexible Spring Boot is. There is minimal overhead for me to do actually go and do this breakup. I just have in particular I'm using Gradle, but the same thing works for Maven. All I need to do is just go in, get the plugin, tell it what dependencies I need from the boot system, and everything works. Cool. Yes.
So when running the same machine, they need to do a different port, right?
Well, they don't listen to different ports. They are connected to a message queue. So if they were listening, if they have inbound, for example, channel adapters, if I was listening to HTTP in any of those, then yeah, I would have to run them on separate ports. In this particular case, they don't have to because there is no conflict. They're all listened to Rabbit to receive their messages.
Can this control multiple sessions or multiple threads within one physical connections made to the MQ?
How do you mean?
So you can have a limited number of connections, but you can have multiple threads running or multiple sessions.
Oh yeah. You can, like, what I'm showing you right now is not, like, there's absolutely no concurrency inside the component itself. But you can have that. Like, we can run multiple threads, and probably that would be also a first sensible thing to do. Like the queues, like in the channels that Spring integration defines, you have an option where you can actually make them buffered. And you have different options of where you actually store the data for those particular channels. So you can make them persistent, or you can make them live in memory. And when you do that, you can actually do multi-threading inside a process. And that would essentially would probably be one good way to start increasing your performance, like just relying on processing on multiple threads. Honestly, I didn't go in that direction because in this presentation, because I was more focused on the partitioning and putting things together than necessarily how things happen inside a particular component. But that definitely is possible. Sure.
The problem definition or the domain of the problem is such that you are able to partition the system and have messaging in place, because the system is so asynchronous in nature right now. Where I place in the order and I'm not waiting for the response to come immediately, I can just wait, okay, the order has been accepted and it's going to get delivered to me. How would you do that in a system which is more request-response oriented or more interactive in nature?
That is correct. Good question. So Spring integration also has an abstraction, a component called a gateway, whose role is specifically to tie even an asynchronous request response into a synchronous type of. So basically, what will happen is that, so you have different solutions to this problem. Let me go back. Either you have a listener that waits for the response, and then you handle it in an event-driven fashion in your system, right? Or you block until the result is produced on the result queue. Now, for the blocking part, which is usually kind of a pain to implement, as I said, there is a gateway component that actually handles that correlating the request and response, even if they're asynchronous. Well, the client has to be, the gateway lives in the same client. So, I'm sorry, maybe I didn't get the question correctly.
What I meant was that here you have the luxury that even when you accepted the order, your processor was
Yes.
not up, and you could drop it into a queue, and when the processor comes up, it's able to take it from the queue.
That's correct.
The system, your gateway has to be ready to accept the request, otherwise it's just going to fail over there, right?
Well, the gateway is the client. Sorry. Can we take the question offline? Because or basically wait to the end. I just want to, like, the point that I'm trying to make is that the gateway is a client structure. So if you want to wait for the response, you have to wait for the response at the time you actually issue the request, right? Because that's what you're trying to do. You're trying to transform an asynchronous scenario into a synchronous one.
Would you still have messaging over there when the gateway would still send to a messaging? Or
Yes, yes, yes. It's basically the gateway receives, like the gateway listens on a queue for a specific message with some specific metadata associated to it that makes it possible to be identified as the response to the initial request. So when the request goes through, there is some decoration that happens in the message. When the response comes back, it says, oh, this is the response to request, whatever. Here it is. You've actually got it.
the correlation that this response is for this particular request that I have sent. It's able to correlate the request and the response that comes back, right?
Yes. Yes, exactly. I hope that answers the question. If not, I'll be able to answer it.
So kind of that same concept, if you do that, how long do you have to wait for the response? Let's say that something goes down, then
It's
time out, you disconnect, then there's that disconnect.
I understand the question. So the question was, how do you want to wait for the response if you're having like an asynchronous and fundamentally asynchronous response reply scenario, and you actually turn it into, like, you block waiting for the response. There are configurable timeouts in the application, but the only way you can actually know how much long do you want to wait is, like, it's something that your application has to say, like, what kind of resilience do you want to have, or because there are benefits and drawbacks. There are drawbacks with, like, dropping too early, right? You have requests that fail. There are drawbacks in blocking because the longer you wait, that's basically a thread that's taken. Yes, it's going to be available. I haven't pushed it yet, but it's going to be available on GitHub. OK. I'll have some questions even afterwards, and then I'm going to be around here. I just want to get to the last part of the presentation, which is, now that we've distributed the system, right? We actually created a distributed system that can process things, that has independent nodes that run standalone, and so on. What's good and what's bad about it? Well, obviously we have a lot of benefits. We're already in kind of microservice territory with this. The question is, who maintains it? Who administers it? Because you actually have to keep watch on those systems. You have systems, you actually have to make sure that they run. You have to monitor them. Like, you have to do a whole lot of maintenance and governance around your distributed system. Right? So again, it's not a free lunch. You get something, you have to give away something. And so one idea here is, rather than doing this kind of do-it-yourself concurrency, which is perfectly possible, and it's a scenario that is applied widely, you also have the option of running the components that we just developed in SpringXD. How many of you have, well, I'm sure you have heard of SpringXD because you've been at the conference, but how many of you have actually tried using SpringXD? One person. Only one. You should try. You should go home and try SpringXD as soon as you get. It's, so what's the idea behind it? Spring Extreme Data, it's a system like a one-stop shop for data ingestion, real-time analytics, batch processing, data export, handling of really performance, handling high throughput streams in a really performant fashion. That's the goal behind it. Fundamentally, it's built on existing solutions such as Spring Integration and Spring Batch. And what does that mean? It means that if I have Spring integration components, I can deploy them without any problem. The key there is the concept of a module. Now, SpringXD allows you to deploy your own components. They're called modules, of course. They have conventions for input and output channels. So essentially, each module is an application context that has a channel called input and a channel called output. Does it ring a bell with what we did so far? Cool. And when you define a stream that aligns these components together, it falls upon SpringXD to do the bridging between channels, between input and output channels. Remember what I said about bridging being not very nice when you have to do it manually. And you have to remember that I have to link channel X to channel Y to channel, and so on and so forth, right? So this is basically where SpringXD comes into place. If I can define my components as modules, I deploy them in SpringXD, and I create a stream out of them, everyone's happy. Like it works out of the box. And this is what I'm going to actually show you. SpringXD modules fall in 3 types of categories. 4, actually. There's a 4th one called jobs, which is not here because it's more of a batch-oriented component. There are sources, sinks, and processors. Sources have only an output channel. Sinks have only an input channel. And processors are no true components. So they have an input and an output. As I said, a string definition will link them together, and they will work out of the box. The other thing that helps, besides the streaming thing, and besides the fact that it does the bridging automatically for us and it does all these nice things, is the management of a distributed runtime. SpringXD is by design, has by design a distributed architecture with with separate containers running on separate instances that can deploy separate modules. So rather than me having to do the whole rabbit thing and starting and doing all the legwork for that kind of stuff, I can just deploy them into SpringXD, and SpringXD will take care of distributing them. Not only that, I can also specify concurrency parameters. If you've actually watched the keynote, I think on Tuesday, Mark Fisher has actually shown that household example. You've seen multiple, in that example, you have multiple nodes doing processing. And basically, essentially, they consist of a stream where I can specify that one particular component of the stream will be deployed in multiple instances. So again, what I tried to do with the drinks, but this time completely managed and without having to do the whole, me having to maintain the whole infrastructure. Basically, what I'm trying to say with all this is that what StreamXD is for extreme data is also for less extreme data. You can get a lot from that, from using its module model, and we will see how you can do that right now. So basically, what I have here in the last part of the demo is, okay, so I've taken what we had before. I've created, again, one project with 3 sub-projects. So what I'm saying is, there are 2 things that I don't want to care about. handling the HTTP input and logging the result. The point being that Spring XD already has components, has sources and sinks that can do that for me. So I'm going to leave out of the solution. I'm just going to deploy the actual business components, and I'm going to create 3 processors. Like you can visualize the stream right here. I'm going to use the native HTTP source for receiving data. I'm going to create a stream that actually has those 3 steps: order processing, drink making, delivery, assembly, and I'm going to write them to the log. Again, this log sync is a native component of Spring XD. So, how do they look like? Okay. Super familiar, right? So this is the delivery. Let me just go to the drinks. This is the drinks component, right? Recognize it, it's the same thing that we discussed, input channel, output channel, except that right now, the input channel is actually called input for this component. Why? Because Spring XD requires it. Same with the output. It's called output because of the convention that will actually allow me to connect to it. And everything else is quite the same. You've seen, I think, the delivery component, again, input and output. You've seen the orders component. You haven't seen it yet, so it has the same structure. And basically, that's pretty much it: an input, output, and the splitter. So when I'm actually looking at the when I'm actually looking at how things are deployed in Spring XD, okay. So they're not, okay. This is where Spring XD is deployed, and this is how I deployed my solution. So, going here. Okay. So, in my Spring XD installation, I have this directory called modules. And inside the modules, I have the different types of modules. I have a ton of them, and I've already pre-deployed the modules that I've created. Essentially, if I go to, for example, cafe delivery, I basically have 2 directories, one config, one lib. The config one has the XML definition of a module. The lib has all the libraries that the module uses. So it's a particular way of packaging this, but it's not particularly complicated. It's just different. And if you want to create your own module, in fact, there are, as I say, I'm gonna push this repository to GitHub, but basically, you can take just the example and look. There are 2 Gradle tasks that just take care of copying the files in this particular structure that you can copy into Spring XD. Okay, so now that we have Spring XD running, let's start it. So I'm going to run in single node mode because I don't have the entire setup for the cluster. Okay, the shell has connected. The containers are initialized. So what I'm going to do next is I'm going to create a stream that ties together, like that creates that structure that I've just shown you. So let me just grab the command because it's longer. It's actually it's pretty long command because of the few a few particularities of this implementation. So what I'm doing here, can everyone see in the back, or let me just, okay. So what I'm going to do here is I'm creating a stream named Cafe that has an HTTP sync input that outputs that basically sends everything it receives, sends it back on the stream as JSON. I have Cafe orders, which is my initial step, and I tell it to deserialize the JSON into an order object and send it back as JSON to the stream. I'm doing the same for drinks. I'm doing the same for delivery, and then I'm sending it to the log. Why I go through this whole serialization, deserialization process, you might ask? Well, you can see if you try to do it without serializing and deserializing. What happens is each of these components runs in its separate class loader. So the objects, like if I'm sending just the object instance across, the class loader will complain about like the service methods not being able to invoke. Like it won't really recognize the classes because they are loaded they are loaded from a sibling class load. One option that you have to solve that particular problem would be to just deploy common types on like in the shared class path. If you feel for something like that, so you don't necessarily have to do this. If you don't want to tamper with the share, if you are comfortable with tampering with the shared class path, or a better solution, and this is another interesting thing to discuss about this modularization process, is not to rely on POJOs at all. They're cool, like they're very cool and very easy and type safe. But the problem with POJOs, especially when you send when you send data around, is that once you change something to a class, you have to redeploy that class everywhere, like to every place it's actually used. Which is why it's quite common to use a kind of a more neutral data format like JSON, or for example, SpringXD has an internal type called tuple, which is essentially a schemaless object that you can actually use for exchanging data between nodes. So,
what do you think about using a map instead of?
Oh, map is okay. Like it's fine. It's fine like that. Tuple has a little bit more than that in the sense that it's ordered. So it's more, and it has a few more methods like which are kind of dedicated to. Yeah, more friendlier than the map itself. But in theory, a map is not, like it's neutral enough to be sent around. Okay, so we have the stream. We have created the stream Cafe. And actually, it's running, so I can see it running in the console. So what are we going to do next is just send one request. So I'm going to send this request. Now, this application listens on a different port. And I can see basically my request coming through. I sent the two. It's kind of the output is a little bit different because I'm actually sending the drink as a JSON to the log. But essentially, it tells me the same thing as the other log, as the other example, that my delivery has successfully assembled an order that contains a mocha and espresso and latte and cappuccino and whatever this example has actually used. And that's pretty much it. Like, it's, as you have seen, deploying and creating the stream. Like, once I've actually been able to get around this whole concept of organizing my application context, organizing my bus as a set of definitions, like, that have a very clearly defined input and output, and I have it put together. Once I have been able to do that, I've been able to create distributed systems by simply connecting channel adapters, or I've been able to take it and deploy it straight into SpringXD. Very, very simply. The only change I have to make to the other example was changing the names of the channels because of the names that SpringXD expects. And that was pretty much all. Well, I had to do a little bit in packaging too, but that's not hard.
Yeah, so we've taken this one monolithic service and decomposed it into all these subservices, and now we got all these different interfaces now available at different points. How does integration or XD help with security in that aspect, going between these different points and services?
How do they help securing? Security.
Having additional constraints at different services.
Right. So you basically mean, because it's distributed, how do we prevent, for example, connecting, like, nodes from connecting and like.
Connecting in or potentially making a drink to make sure that the consumer is of age or something at a lower level or something.
I'm sorry. Like, I was thinking more of a security in the sense of like access.
This primarily.
Yeah. Well, that's an upcoming feature. So securing, like, establishing, like, completely securing the, like, making sure, securing the various nodes. Like, right now, nodes connect based on what they see around. Which is actually not extremely secure at this point, unless you're running, like, it is secure if you're running in a managed environment. So you have access to, like, if you do it, for example, in a virtual network and you restrict access to whom can actually enter there, then it's secure. But if you want to use it over a wider network, then yes, you will need some upcoming features that restrict access and restrict who can connect, for example, to who can become a node in this system.
Right now, it's your responsibility, your interface, to deal with that each level.
Yes. So, yes.
It seems to me that from you've broken this application into 3 modules, and then you are deploying it in XD. It almost looks like it's a container kind of thing, right?
I'm sorry.
The XD part of it, where you define the modules in XD,
Right.
seems to be done in the XD directories.
That's correct.
Your source, right? So,
That is correct.
it seems like it's almost like, deploying for Tomcat. I'm not trivializing.
I understand.
It looks like external to your source.
I understand what, like,
So given that, I mean, are we delivering, for example, do you have to configure XD to say that use AMQP for the transport between
Right.
the 2 modules? All that happens inside the XD ecosystem, outside the application, right? So it's not when you, for example, when you push this to GitHub,
right.
you also take care to push the XD part of it, or how do we get a complete solution?
Okay, so so there are 2 questions. One related to so communication between the nodes, the way it happens. It basically, like, in a distributed scenario, it happens to, like, it happens through some distributed channels like Rabbit. So that's one thing. Deployment, on the other hand, right now, you can, like, for deploying a module, you need to have access to the installation where you're deploying the module to. So if you're installing into different machines, you will have to install it into different places, or have a shared network folder that you mount, and then they can both see. However, like one of the upcoming features would be to have a way to deploy things in a more centralized way, so that you don't have to deploy each. You don't have to deploy a module on each instance that actually is part of your cluster. I hope I got the question right.
Well, the second part was what is the complete solution? Is it just your project in which you broke out the 3 modules? How do you encapsulate the configuration you did in XD in your solution? For example, where do you tell XD to use AMQP, what ports, where does all that happen?
Well, that's built like, okay, I'm sorry if I got the question right. So the question is, how do I tell XD to use AMQP or to use other different types of transports? It's through command line attributes. So when you start it, you can tell the runtime to use different transports for communication between nodes. Mark is here, and he's the project lead for. But just.
That YAML file outside of your solution, right?
So it's completely analogous to how you deploy things into the content. It has some configuration files, the artifacts, you ship them over to the content, and you deploy them. So that the life cycle is generally mimicking that. And you mentioned that the class loader hierarchy is also mimicking the same type of hierarchy you see in the physical web application.
Okay.
So when you separated the application into 3 different modules, you still had these domain objects like drinks or order
Right.
that were used by all the 3 modules.
Right.
How did you take care of those domain modules, the domain objects?
Well, because they are all of them, because they live, as I said, because they live in separate class loaders. You have, like, okay, this has to do more with the class loader model. Each module gets its own class loader. So because I've deployed them, essentially I had to have an instance of order in each of these modules. Now, normally that would be done, for example, by having a shared jar with domain objects that all of them can include. The other option is to have, for example, to deploy, to put such objects on the shared class path. But you don't necessarily want to do that, because that's kind of tempering a little bit with your runtime. So that's some sort of a maintenance nightmare. In my opinion, however, the best way to handle the differences between, to handle the transport issue of such objects is to pass really like schemaless or like some neutral formats between modules, and so basically avoid having like class loading problems or anything like that.
So that takes care of your exchange format, that you're able to get your data across, but then once it gets inside your module, you still have to instruct it.
There are, sure. If you look, for example, at the command here, it's doing something like this, but I'm using the I'm using native support for that. So basically, what I do is I'm serializing every output as JSON, and I'm instructing, because SpringXD does some automatic data conversion if you tell it to. In my case, for example, I tell it to convert whatever JSON comes as input to cafe drinks, to hydrate it into an order item. And that happens out of the box. The module itself has no idea of how the conversion takes place. Of course, you can do it another way. You can have the transformer, you can have the type converters, you can have Spring type converters inside your bus, inside your module. That's option number 3.
Quick question. I think that part of the question also has to do with the definition of domain objects, right? In this
Right.
case, it would be domain objects, data plus behavior.
Well, if you want to preserve behavior, like if you want to, like if you follow a rich domain object model, if you want to preserve behavior, then you have to recompose into the same class or an equivalent class in the target module.
All things being equal, would you suggest a big rich domain object that would have behavior that in this case, for instance, might have to do with all 3 modules, or to have different objects in each module that have the behavior that is that's necessary for that module?
I would definitely suggest the latter, like off the top of my head. Now, in a different scenario, the answer might be different, but off the top of my head, given that these are really designed, really meant to be standalone components, I would try to minimize. I mean, okay, unless it's actually some kind of library, some kind of utility or something like that, what's the point of actually creating a distributed solution if you're putting everything in one place?
I would like to answer his question that he just asked.
Please.
In yesterday's talk with Matt Stein, he was referring to this concept of bounded context. So the bounded context would mean that you can take your schemaless value object representation and bring it into a bounded context and convert it to a object that you and apply the and in that context the domain object would look different depending on
Good. Like if you're using, so,
apply the logic.
sure. Thank you for pitching it.
The string you've defined here, how will we scale the baristas as we've done before?
You would basically have to add a deployment parameter. So when we define it in the it's cafe drinks, the same way I specify the input type, I can give it a property which says on how many nodes it should run. And provided that there are as many nodes in the system, mind you, this example is run on a single node installation, but it doesn't have to. It just don't have the whole setup for the distributed example. If there were multiple nodes, like I'm pointing you back to the schema here. So essentially, if there were multiple containers to run modules on, and they were available, those modules would be automatically scaled on multiple containers.
That scaling would be pure to Spring Batch, not necessarily requiring the resource manager. In other words, something that stands in place of Yarn, or would you have to define an application manager in that case?
You can run on Yarn, like with Spring XD as well.
So in this scenario that you defined where you just described using multiple nodes and scaling them, maybe not. I'd like to know how to scale them without having a fixed parameter in the string that says I always will only use 2 nodes for barista. But in any case, if I were using Yarn, that's what I would expect.
Okay.
Yeah, I can answer the question.
Sure.
I mean, if you're using Yarn or anything else, Yarn itself doesn't provide you automatically +1. You still have to code to say I like the dynamic scale. That's not a feature that we currently have either in the standalone sort of cluster or within the Yarn cluster. So that dynamic scaling up and down will provide it. Work done, for example, on Cloud Foundry right now, where XP is a service on Cloud Foundry, where it does have that capability. So right now you're stuck with the number you picked during deployment, and then deploy that model, redeploy it with a different number.
And that number acts as the high water mark for
Yeah, in that sense you have to scale this as you scale something traditionally.
Okay. If anyone has any questions, if not, you can always drop me an email or find me on Twitter. Like you have my Twitter handle. Thanks a lot for attending. I hope you have a great conference. And